All right, so last lesson, we skipped 5.4, okay? So on 5.3, what was the title of that lesson?
Inequalities.
What's this one? More inequalities, all right. So it's a little different. It's still talking about comparisons, right? We're going to compare one side to another, one angle to another. But before, on the lesson we just went over on that homework, 5.3, we compared angles in one triangle, didn't we? We took one triangle, we looked at the angles, and we saw which side was bigger, which side was smaller. We took a triangle and we looked at the sides, and that tells us what angles are bigger, right? What angle's bigger, what angle's smaller. But now what we're going to do is we're going to compare not just the stuff in one triangle, we're going to compare the stuff from one triangle to a different triangle, all right, to another triangle. You with me on that? All right, so it's a little bit of a difference here. Let's do this. Let me scooch this up a little bit.
Ethan Patton's office for dismissal. Connie Patton's office for dismissal. Thank you.
All right. There's a spot out here when you go through the hallway. You know the hallway that goes past Cheadle's room, Mrs. Norris's room, at that door right there? Okay. So here's that door, all right, and there's a path that goes, tell you what, I'll use a straight line. So there's a path that goes like this, right? And then if you go to here's the road, right? The sidewalk goes here. So what did they, well, you were probably little kids when they built this, but you understand, here's Mrs. Norris's room right there. You're going out this way, this is the room, this is the elementary building right here, okay? And here's the modulars out here like this. Everybody got that? So it used to be, a bunch of years ago, that you'd have to walk out here all the way to the sidewalk, then you walk down the sidewalk, and then you could walk to the modulars, right? But now, what do they have in there? Yeah, they have like a paved like walkway right there. Do you agree? Okay. So why do they have that? What do you think was there before they put that pavement in there? Those bricks or whatever they are. What do they call those? Paving something. I don't know. Paving bricks. I don't know. Pavers. Excuse me. Yeah, there's some name for it. Because what do you think people were doing? Were they actually going all the way to the sidewalk and then walking all the way to there? No. What are they doing? They're cutting in the grass. That's right. So there used to be this dirt path, right, because people were doing this. Now, it's because people knew geometry, because they were very good geometry students, and they would cut through. Okay, what was the reason for them cutting through? It's shorter. It's quicker. That's right.
There's a picture in our book.
There is a picture in the book. Yeah. What page is that?
234.
234. All right. Yeah. There is a book. There is a picture in the book that kind of describes it. I don't have it here. If I would have been a better teacher, I would have screenshotted it or something and put it on the screen. But I'm not a good teacher, so we'll just leave it at that. But remember, I did tell you that I took a picture of the actual sidewalk and I did it. So at one point, I was prepared, but I just can't find it now. So anyway, the point is, if you wanted to go from here to here, is it better to go all the way here and then all the way to there? Well, you're on a nice sidewalk, okay, so it could be better, but which is the shorter distance? What's the most efficient way to get from here to here? It would be going in this direction. Wouldn't you agree? Why? Because it's shorter. Everybody see that? Because on a triangle, what must be true about these two lengths? If I go this length and I go this length, those two lengths will always be longer than that direct route. Agree with that? Yeah, so remember we talked about yesterday, the shortest distance between 2 points is a what? Is a straight line. Exactly. All right, so instead of going this way and then this way, this is a better distance. So what must be true about this side and this side compared to this one? They have to add up, or they're going to be greater than, right? Let's call this A, we'll call that B, and we'll call this C. So the length of A plus the length of B has got to be what compared to C? Greater than, right, not equal to. Because if it was equal to, everybody would just go down the sidewalk this way and this way, wouldn't it? If it was the same distance, but it's not. This one's shorter. All right, so A and B must be greater than what? Than C. Does that make sense?
Yeah.
That also means that C has to be greater than A, and C has to be greater than what else? Than B, right? Because if it's, everybody understand that? Because these two have to add up. I'm sorry. I don't think I said that right. Let's stop before I said that, okay? Let's rewind and pretend I never said that, all right? So, but this is okay right here. That's exactly what we want. Does that make sense? All right. With all that said, it's leading up to something, okay? We're going to talk about something right here. And it's called the triangle. We'll write down the name. Then we might forget it later, but that's fine. I just want you to understand what it says. That's what I care about. I don't really care about the names that much. I care that you know what it does. Triangle inequality theorem. And let's see what it says. I'll write it down, okay? I don't usually write down a whole bunch of these theorems, okay, but I will this time because I think it's pretty important, all right? So here's what it says. The sum of the lengths, write it down. The sum of the lengths. Not everybody's writing. I can see in my peripheral. People are just sitting there looking at me. Thank you. The sum of the lengths of any two sides, I'll just keep that right there. Any two sides of a triangle is greater than the length of the third side. The length of the third side. All right, follow me on that? Does that work with what we talked about before? The sum of the lengths. What does it mean, the sum of the lengths? What do I do when I say sum? Add them up, right. Okay, so when I add up the lengths of any two sides, it doesn't matter which two sides. Now I added A and B together, but watch. The sum of the lengths of any two sides of a triangle, not just a right triangle, any triangle, is greater than the length of the third side. So this triangle right here, if I add up any two of the sides, I could add A and C. This is what I was getting at before, and I kind of messed it up. If I add up A plus C, that's always going to be bigger than what? Than B. If I add up B and C, that sum, the addition of those two, is always going to be bigger than what? Than A. And if I add up A and B, it's always going to be bigger than what? Than C. Does that make sense? So here's what they're going to do. It's actually, the problems that they give you are actually, they kind of make sense. I have in my notes to use GeoGebra to demonstrate this. And again, lack of preparation. I probably should have practiced this, so beware. I may mess up a little bit, but I think I might be able to figure it out. So GeoGebra right there. Let's get rid of that. There's GeoGebra. I want to do a demonstration. Okay. So let's do this. I think I can do this. I should have practiced it. I think there's a thing where I can make a length a certain side. Let me just see. Make a segment. Oh, segment with a given length. Yeah, perfect. Select a point, then enter the length. All right, so I'm going to call this length 9. And there it is. We'll zoom up a little bit so it's not so small. Okay. Oops, stack on it. Let's forget. Let's get rid of that. Let's zoom up again. Yeah, there we go. Oh, why do I keep doing that? I gotta hit escape. And now I can do that. Okay, I was sorry, already messing up. And this is the easy part. And so that's 9. I'm actually going to put the length on here. Yep, there it is. That's length 9. Everybody good with that? All right. Let's do another length. And I'm going to call it 5. Well, let's call it 6. Nope, no 7s. All right, and then I'm going to click on that. The distance or length. Got to click that first. There we go. There's 6. Everybody good so far? All right, let's do another one. This will be the last one right there, and I'll call this one 5. And let's click on it and find the length of it. There you go. There's 5. Everybody okay? I wonder if, yeah. See, I'm trying to stretch this thing out, and it won't stretch out. It won't make it smaller, won't make it bigger. It's going to stay 5. Everybody go with that? What I want to do is I want to figure out, can I make a triangle with those 3 lengths? And a lot of students, and I don't blame them because I'd probably think the same thing. A lot of times we think that you could take any 3 sides at all, and be able to form a triangle out of them. But think about it. What if I had a side that was like 3? What if I had a side that was 5? Then I had another side that was 100. Is there any way you can make a triangle with those 3 sides? No, there's not. Okay, if I had a 3 and a 5, doesn't matter how I make it, that 100 is going to be way too long. It's not going to be able to connect. Agreed? I was being ridiculous with the 100, but just to get you to visualize what's going on. Can you make a triangle with this? Well, let's see if we can. So let's take this up. Well, let me hit escape. I think that might help me. Oh, I can't even move it. What? It's not letting you move it? Well, you know what I can do? Tell you what, sorry. I told you, I warned you, didn't I? that about this. What I can do is this. I got to click here. That's what I got to do. And then I'll put a 6 and then hit OK. And then I can actually move it around. I can't make it bigger or smaller, but I can move it around like this. Now I'm on to it, okay? Everybody with me on that? Yeah. And let's name that, or not name it, but give it the length, just so you remember. There it is. And I will, let's put that 6 on the outside, since that 9's on the outside. Now, what I want to do is make this. I'll click on this. And what did I say I was going to make it? 5. All right. And let's name it, or not name it, but give it a length, just so we can see it. There we go. All right. So now what I want to do, I got my 3 lengths. Would you agree? Can I make a triangle with those 3 lengths? Let's see. Well, I'd probably have to move that up like this, wouldn't I? And I probably have to move like that. Still doesn't connect, so I'm going to make this go down a little bit, make this go up a little bit. You see what I'm doing? I'm not changing the lengths of these at all. If I can grab that D. Well, you get the idea. You can make a triangle out of those. Would you agree? They don't hit dead on perfect because I can't quite grab. There we go. And then let's grab this one. I think. Oh, I just grabbed the C. Anyway, you get the idea. So you can definitely make a triangle out of those 3 lengths. Yes? Yeah. All right. So let's go through the theorem. What does that theorem say again? It says the sum of the lengths of any 2 sides has to be what? Greater than the 3rd side. So take any of these 2 sides. I don't care. Which side do you want? The 6, the 5, or the 9? Or the 6 and 5, or the 5 and 9, or the 6 and 9? 6 and 5, okay? So 6 plus 5 is 11. Is 11 bigger than 9? Okay. Take the 5 and the 9. What's that? Add them up. 14. Is 14 bigger than 6? Yeah. Okay, what are the other 2? 6 and 9, right? Add those up. That's 15. Is 15 bigger than 5? If that's true, then you can make a triangle out of it. That's all we're trying to do right now at this beginning part, okay? We're just trying to figure out if you can get a triangle out of it. So let's put some numbers on there that you cannot make a triangle out of, all right? So let's go 6, 9, and 2. So let's get rid of this. We'll keep the 9 there. Let's get rid of this. And let's get rid of these. Would I say, let's put another 6. I had a 6 in there. Could have just kept the 6 there, shouldn't I? Was that the last one that I did? Nope, it wasn't. So let's get rid of those again. All right, let's do it again. So let's make another segment. Let's start here. What do we say we're going to make it? 6? Okay. All right, there it is. Tell you what, I'm going to stretch it out to there. Everybody good? And we'll call that a 6. So, oops, I got to click that first, then that one. There we go. Okay, so there's a 6, and there's a 9. Okay, what was the other number that I said? 2? All right. That's in my notes. That's the only reason that I use that. So we're going to click here. We're going to put a 2 in for that. There we go. And let's find the distance or length of this. And there's the 2. Now, can I make a triangle out of these 3 lengths? Well, let's give it a shot. Watch. Let's take that to there. Let's take this one to there. Will I get these to match up? No, I got to take that a little closer. Look at that. There's no way I can make a triangle out of that. There's not enough room. Would you agree? All right? So mathematically, let's put these up a little bit more. Let's put this one out here like that. So mathematically, let's see if it works. Do I have to use GeoGebra? Do I have to draw things and figure out? No, we can just do some math on it. So what I would do, what always works, is taking the 2 smaller lengths, adding them up, and seeing if it's bigger than the third one, okay? So that's, you could do all 3 like we did earlier, but really it's better if you take all, or just the 2 smaller ones. Which ones are my 2 smaller ones? 2 and 6, okay? If I add those up, what do I get? 8. Is 8 bigger than 9? No, it's not. So do you see that gap? If it's not bigger, is there any way I can get them to meet? No. What if this, I wonder if I can do this. I wonder if I can change the length. Let's just delete it. And delete this. Okay, good point, because that's exactly what I was going to do. All right, so let's put a what in there to make them equal. Put a 3 in there. Let's see if I can make a triangle out of that. Okay? I might have to zoom in a little bit. That's okay. Watch. I'm gonna. Looks like it makes a triangle, doesn't it? But if, oops. But what if I zoom in a whole bunch? Look. Get rid of that C. Oh, that C's right there. I want to grab this. That's what. Look. It still doesn't hit, does it? If I zoom in some more, say I'm just zooming in is all I'm doing, all right? And it's not going to hit. What if I move this down and I move this down even closer? Still not hitting, are they? Are they ever going to hit? Once they get all the way to the line. Exactly right. You got it. Okay, so watch. The only time they're going to hit is when that goes to there and this one goes to there. Boom. Now they hit. But is that a triangle? No, because there's no space in there. There's no angle in there, right? It just forms that line. So if the 2 smaller ones equal the third one, do you have a triangle? No. So what has to be true when you add those 2 smaller ones up? It's got to be greater than. It's got to be bigger than that third side. Does that make sense? Okay, good. Well, that was fun, wasn't it? See? They just make a straight line. But as soon as you start doing this, right, they're not going to touch, are they? No. So you can't have a triangle with that. Now, in that first one, when I used 5, 6, and 9, does it have to, when you have a 9, does it always have to be a 5 and a 6? It doesn't have to. It can be any numbers as long as when you add those 2 numbers up, it's going to be bigger than then the third side. You got it? Okay. All right, let's move on. Let's take this back to that. Say what? 302. Oh my goodness, that's right. This class is super short. Well, we'll finish this up tomorrow. Yeah. We do. Well, he wasn't here because a bunch of them left when we talked about it. We will have class tomorrow, and we'll finish this lesson tomorrow, okay? I completely forgot it being Wednesday, and I wasn't looking at the clock, but it's too late to do anything else with this. So that's today's lesson. Tomorrow we'll finish it up, and then I'll give you homework. So no homework tonight. Unless you want to read on and do it yourself, like on your own. I'm not saying you have to, but if you want to do it on your own, feel free. All right.